G'day, how you going? And welcome to the first episode of Over the Moon, the podcast where I talk about all news space related, from theories of the creation of the universe to updates about rockets. This is the podcast to come to for space news, updates, and all the facts. So today, in our first episode, we will be talking about different theories of creation. Not just the Big Bang Theory, I'm also going to be talking about the theory of the creation of the moon. So it's not just one thing. So, with the Big Bang Theory, it suggests that the universe, at first, was tiny. The smallest thing ever. So small you can't even comprehend it. They said it was 100 billion trillionth of a meter across. And it had all of the stars and all of that heat all built up in one tiny area. You know, if a bacterium went past it, it wouldn't even bat an eye if they had eyes. So this is called a singularity. So it's boiling hot, but then in 100 million trillionths of a second, it just went bang. And it expanded. The Great Expansion, the Big Bang Theory. But it probably wouldn't have been much of a bang, seeming as it happened so fast that you wouldn't have even been able to hear something. So the reason that it expanded is because all of that energy and that heat, it cooked together. It cooked photons, and photons then create electrons, quarks, and some other things that aren't really important. So that sparked the entire universe. But with photons, one of the great discoveries, every action has an equal reaction. So creating electrons and quarks also creates anti-electrons and anti-quarks, and making antimatter. And antimatter and anti-electrons, they annihilate each other. They track down each other and destroy each other. So you can't have them ever, because they just try and destroy each other. This is due to something called the conservation of charge. What it says is, in an isolated system, the total electric charge is always maintained. But for some reason, during the Big Bang Theory, more matter was made than antimatter. So there is still matter. Now the amount of, we actually know how much matter and antimatter would have been created if this theory is correct. It would have been 1 billion antimatter but 1 billion and 1 matter. So this has very small possibilities of happening. That's why it has such little amounts, you know, 1,000,000,001 to 1,000,000,000. So that's the short version of the Big Bang Theory. There's much more science and everything behind it, and that's just the Great Expansion. There's much more to it. So, the reason energy creates, so photons, that's pretty much light. So a photon is like energy, and the tiny singularity had enough energy to create the mass of the entire universe, and you can figure out the exact amount of energy using one of Albert Einstein's great discoveries, E equals mc2. So, you've probably heard of E equals mc2, but you have no idea what it means. It is actually quite simple. So the E stands for energy, which equals mass times the speed of light squared. Okay, so the speed of light is almost 3 million meters a second. The speed of light is, it's the distance you would travel. A light year is the distance that you would travel if you are traveling at the speed of light in 1 year. And because it's so fast, you can go really far in a light year. So the universe, after the expansion, was a few light years across. So that's a very big amount. Yes. And that all happened in less than a second. So after 0.00001 seconds, 5.501 second, the universe has expanded to the point where it's too cold. It's after 1 second, it's a few light years across. And it's now too cold for photons to be cooked. So we can't create any more electrons, quarks, or any of the other stuff because it's too cold. My notes are very jumbled up. So we can't make any more matter, but we've already got enough matter for the entire universe. So 1 light second is 300 million meters. So quite a long distance. Now, to actually create mass, we've only got matter, we don't have actual mass. We need to create atoms. And the easiest atoms to create is the hydrogen atom and the helium atom. The hydrogen atom is 1 proton and 1 electron. The proton's in the center and the electron is circling it. You may have seen it. And that creates hydrogen. But at the current time, all electrons are actually going way too fast for them to actually be caught by a proton. So, 380,000 years later, we went from stuff happening in seconds to 380,000 years. Now the universe is cooled down to 3,000 Kelvin, and the electrons have slowed down enough to be caught by a proton. So 3,000 Kelvin is half the sun's heat. So it's still super hot, but less hot. So now that atoms can be made, we can have mass. So the second easiest atom to create is a helium atom, which is 2 protons, 2 neutrons, and 2 electrons. Now this is the one with four circles in the middle and 2 circles orbiting it. Orbiting is, circling around it. So it has 2 electrons circling 2 protons and 2 neutrons together. But before that actually happened, the entire galaxy, the entire universe, was full of electrons. Now photons can't actually pass through that because of the electrons. Electrons bounce off photons. So when you see something, it is light being transferred from that object to your retinas, and that is how you actually see stuff. But because the electrons are bouncing the photons around, you can't see anything. So you can't see anything, and you need the electrons to all disappear for that to happen. So because the electrons have slowed down enough to be caught by photons, they can now be dispersed into atoms, which would mean that photons can actually pass through the universe, allowing you to see. So that happens, and all of the electrons get caught by the photons, and now we can see. Yay! 3 cheers for electrons and photons. 3 cheers for photons. So, that solves our problem of not being able to see. Now, a little interesting fact. This part isn't the interesting fact. Atoms release photons, the light. So atoms are releasing light, and the photons leave imprints as they travel around. Now, you can actually see these imprints when you turn on the TV. White noise is 1% photon imprints. That's pretty interesting. Now, the people who found this, they just thought that that sound, the white noise sound, was just bird poop messing with their satellite. Little did they know they just found something out. So, I think that explains everything, except for one last thing. Now, 2 atoms can join to become safer by sharing their electrons. So they connect, and then the electrons are in the same spot, and it creates like a sort of an egg around it. Now, a very easy way to see how many protons are in a atom is by looking at the periodic table. Now, the little number in the top left corner is how many protons. The periodic table reads just like you do a book, from left to right, then down. So the first one is hydrogen. The first one on the periodic table, the first period is hydrogen, and in the top left it's got 1 because it has 1 proton in it. Then the second one is helium because that has 2 protons in it. Now the protons actually make it heavier. So that's why we use helium and hydrogen gases in balloons, because they're lighter than oxygen, which has like about 20 protons, I think. I didn't actually check. Now, water is oxygen, 2O. Wait, no, O2. Oxygen is O2 and hydrogen is 2O. Now, I mean H2. So oxygen is 2O, O2, O2. Oxygen's O2 and hydrogen's 2O. Now, when they combine, they create water. Or H2O. That's why it's H2O, because it's the 2 ones combined. So that's the most basic explanation of the Big Bang Theory. And I still haven't even gotten to the whole universes, the whole galaxies and planets and stuff. So it's really elaborate, the Big Bang Theory, and pretty plausible. I don't believe we have any actual facts, but it's still a plausible thing. Now, next is the creation of the moon. Now, there have been a few theories, especially before the Apollo missions, the missions to the moon. there was quite a few theories on how the moon was created. You know, one of them was that we captured the moon as we were flying around. One of them's that another planet collided with the Earth. One of them's just that I believe that we just collected asteroids over time and eventually they all formed together to create the moon. They're all decent theories, but then we landed on the moon and we got to take rock samples, and they especially circulated around one specific theory, and that is the theory of another planet colliding with Earth while it was still getting created. Now, that planet is called Theia, Theia. The planet is about the size of Mars. Mars is about 2/3 smaller than Earth. So it came and smashed Earth. It collided with Earth, knocking rocks out into the Earth's orbit, which over time connected to create the moon, which is why the moon looks, and the moon's rocks and dirt is fairly similar to that of Earth. But it's not the exact same because it's not oxidized and it would be part Theia. So the impact would have been 100 million times stronger than the asteroid that collided with Earth, killing all of the dinosaurs. Interesting fact, there's actually a conspiracy theory about that dinosaurs didn't exist. You know, the crazy people who create conspiracy theories have come up with dinosaurs were just invented by the government to trick us for who knows why. You know, the government, you know, they just like tricking us, but that has nothing to do with space. So and the other theory that I spoke about was the capture theory. So Mars has 2 moons called Phobos and Deimos. If you've seen them, they're pretty oddly shaped, and they weren't actually ever a part of Mars. They were captured, and I believe most other moons were captured as the solar system and the planets fly through space. So the theory is that the moon was our moon was preformed who knows where, and then as the solar system and we were moving around, we caught it in our orbit, and since then it's been orbiting us. Now this one has a couple problems. Now, as I said, Phobos and Deimos are very strange shapes, and most moons from that have been just randomly captured are pretty randomly shaped. And also the orbit of the moon's orbit of the Earth is pretty elliptical, pretty circular. It's pretty perfect. Whereas if it was caught from the middle of space, it would have been a bit different than that. The other theory is pretty interesting, and that is that Earth stole Venus's moon. Now, Venus doesn't actually have a moon, so that's got some people interested, and they think that Venus's moon might have somehow been slingshot, or we somehow caught Venus's moon, which means Venus now has no moon, but we do. It's an interesting theory, but it just doesn't sound plausible, you know? I mean, us taking a moon from Venus? I mean, I doubt it would look the same, you know? Like, you look at Venus and that's all red, you know? It's super hot, you know, one of the hottest planets in our solar system. That wasn't at all factually sourced. I don't actually have a script. I'm just guessing it is. It's the second planet from the sun. The first planet being Mercury. Yes, I'm not very sure with that one. So now on to our random segment of the day. I'm just going to be talking some random stuff. Starting with the image that you can see. That is M31, the Andromeda Galaxy. It is our solar system's closest... it's our galaxy's, the Milky Way's, closest spiral galaxy. It's not our closest galaxy though. Our closest galaxy is actually Alpha Centauri, which you may know if you watched a show called Lost in Space. Earth gets overpopulated and they have to leave space. Something else that I'd like to comment on is that our names, the first names for the stuff we have, suck. Like, starting with the Earth. Our name literally just means dirt and rock. I mean, Earth. You know, you look at Venus. I mean, Venus, Mars. Mars was named after the Roman god of war. I mean, such a great name. So strong. And then we're just called dirt. So, that kind of sucks. And our moon is just called the moon. You know? Saturn has like 52, between 50 and 60 moons. And they all have separate names. I mean, some of them aren't that good. I mean, there's a moon called Io, but Ganymede, Titan. There's a moon called Titan. I'm not entirely sure if it's Saturn or Jupiter's orbit, but some people are actually looking at it as for colonization, you know, space colonization. So that's pretty interesting. You know, we could colonize a moon. We could colonize our own moon, but that's just called the moon. I think another name for it is lunar without the R. But I just saw that while researching facts. And our sun, well, our sun is just called the sun. I mean, it's a bit boring, don't you think? I mean, just the sun. So they could have come up with something more creative. I don't actually know the names of any suns. But other suns have actual names. But also, other galaxies do just have, and planets and stuff do just have letters and numbers as their names. So it could be worse. But it's just something that you can think about, you know? I've said, you know, a lot in our first episode. I'd just like to say the next episodes will be a lot more professional. I'll probably have a script and everything. Maybe flash up some pictures to do with what I'm talking about. But for now, this is what we have. And I quite like it. Yes. Just some interesting things to think about. One interesting fact that has nothing to do with space. The brain there's been studies to show that the brain thinks best when it's not trying to, and that's why weird thoughts happen in the shower. Another thing, if you were born after the year 2000, your entire life there has been at least one astronaut, one person living in space. Because the ISS, the International Space Station, since 2000 has always been filled with people, which technically makes us a spacefaring civilization. So if you were born after 2000, you've lived your entire life as a spacefaring civilization. So how does it feel? I can tell you, it's pretty great. The space station that actually inspired the International Space Station was called the Mir. It was a Russian space station. So that's pretty good. But this is where we're going to end the podcast. I may be uploading a podcast episode 2 on Sunday. Make sure to like the podcast. Maybe listen to it to put you to sleep. I don't think my voice could put you to sleep. Maybe it can. That's for you to find out. But I'll see you. Well, you'll hear me on the next episode of Over the Moon.